Hello, so we are going to take a tree question. Yeah, it will work fine. So the question is recovering a tree from a pre-order traversal. Okay, let's wait. Okay, now it is visible. Recovering a tree from pre-order traversal. So using a pre-order DFS on the root of binary tree, at each node in this traversal, we output D dashes, where D is the depth of this node. Then we output the value of this node. If the depth of that node is D, the depth of its immediate child is D plus 1. Okay. If a node has one child, then child is guaranteed to be the left. Okay. Given the output S of this traversal, recover the tree and return its root. So this is the traversal. 1, 2, then 3, 4 to 5. Okay, then 5 to 6, 6 to 7. So it is a tree node actually. So what? Sorry, we have a string. Um, at each node in this traversal, we output D dashes, where D is the depth of this node. Okay. So depth of first is 1, depth of 2 is 2, depth of 3 is, okay, it is why there are 2 dashes here. We run a preorder. Okay. At each node in the traversal, we output D dashes, where D is the depth of this node. Then we output the value of this node. If the depth of a node is D, then the depth of its immediate child is D. Okay. So the depth of 3 is 1 plus 2. Depth of 4 is, okay. So here we can understand it better. 1, then dash 2, and dash 3, and triple dash 4. Okay. So this is pre-order traversal. We will traverse the string until unless we are getting 1, 2, 3, and 4. Yeah, so if the length is 1, this is 1, then it means it is it is child of root node. If length is 2, then it is child of root node. Okay. So for 6 and 7, we are finding 2 dashes. Similarly here, for 2 and 5, we can find 1 dash. For 3 and 6, there are 2 dashes. For 4 and 7, there are 3 dashes. Okay. And as it is pre-ordered, we can create a node. So we are going to start from root node. Root node is always at first. This one, because it is pre-order, so it will be at first. So we have to recursively define our solution. Okay, let's see. We have a root here. Okay, and there. Okay, so this might be the tree. This might be the case. This and this. So what we will do, we will start from root, create a root node, and put the string's first value as this. Then we will check the next string. If its length is like dash length of dash, number of dashes, not length. Instead of length, I should use num number of dashes. If it is equal to previous number of dashes, like if I'm I have this one 1 dash 2 double dash 3. Okay, then we have 4 double dash with 5 with single dash, then 6 with double dash and double dash, and have 7. Okay, so this one is our root node. It is fixed, kind of fixed. Now until and unless I will find another single dash, this all is part of left root node. So if k is number of dashes after any node, okay. So if k number of dashes after any node, dashes k after ith node, then it means that its level is that ith level. Okay, yeah, at ith level. So what we will do again, yeah, first is there, then whatever will be the next one, 1 then 2, we will put it in the left side. Okay, we can create a pre-order traversal. No, so root dot left will become 2, and the next one single dash is here. So we can do this. Our function will be like create tree. Okay, so it's a recursive function. Let's define a function create tree. Okay, create tree from given is root is given at the initial point. So if not root, return. You don't have to create any tree if the root is already null. If not, okay, if not root, then return else. Create tree for root dot left, and same create tree for root dot right. Okay, the another parameter here will be our string s. So initially I will pass whole string, but for root dot left I'm gonna pass only this string, and for root dot right this string will be passed. Okay, so to keep track of this ith, I will also gonna keep track of ith level. Whenever I'm calling root left and root right, I will be increased like I plus 1, and here I plus 1 too. Okay, so at each I will find all the dashes with ith number. Okay, it will work fine. And there's one more condition. If we are at um, if a node has only one child, that is okay. If yeah, for each of the dashes we will try to find the count. If we found that the string is empty, okay, if right string is empty, or yeah, right string is empty, then no worries. If not root, or string, if not root, or not string, not as something, then also it will return. Okay, this might work. Let's try to code it. Okay, so at first it would be better to create a inner helper function. Do we need that? Okay, yeah, we need that. We need to keep track of all the dashes. Yeah, so can the tree node which we are given could be 0 or not? No, nodes are in range 1 comma 1000. We can start with if there could be 1000 nodes, then the height could be 1000 also. So yeah, so we are going to traverse this array, and whenever we will find a dash, we will try to count how much dashes are there. When we have found all the dashes, we take the count of those dashes and add it to the array. Okay. What if we have three dashes here? So if we are having three dashes here. Okay. One second. 1 dash 2 and dash 5. No, not this. Yeah. 1 dash 2 dash 3 4 5. Okay, there are four element like 3 4 6 and 7. These all are with two dashes. Okay. So what I will do is I will start appending these dashes. Okay, could there be another way? No, okay, 1000. If 1000 is our limit, we can do it in order of n square too. Like we will go to each node and find the next dash by recursing it. No, I mean traversing it. So when I went to 1, I will loop it till next dash. Okay. Yeah, but why should we do that? Why would we do that? Instead, we could keep track of all the dashes and in the dictionary. Okay. Let's take a dictionary. Dash count, not dash dash node. Dash node count. Dash count of each node actually it is. So most probably I have to write this. It is count dash node equals default date of list. It will contain all the indices of okay, it will, yeah. One second. I could have optimized it in a better way. If it is dash and the next one is dash dash, yeah, it won't be bad if I will try to traverse the whole string at any instance and put all those string inside. Okay, yeah, it's better to traverse it because we are going to traverse it only one time. Yeah, here if we are traversing it, not one time, more than that, but it will work. It won't have any problem in here. So yeah, I have defined it. I will try like follow-up will be there that using default like instead of brute forcing to find the dashes. Okay, I can simply use the count dash. Okay, the next dash. Okay, let's see. Define helper. This will help to recover from pre-order. We will have our string. Okay, so we will have our string and we will create a tree node. Okay, so it will be our root is equal to tree node, and if it is a string, I have to use int of s of 0. Okay. While would I in s, no, let's take a index I equals to 1. Okay, while I is not equal to a dash I plus equal to 1. Okay, if while not I, s of I, while I is less than length of, every time we are going to pass a new string, so it would be better to use length of s. Instead of using length, we can also use left L and R. Yeah, that would sound better. It would sound better. L and R. Okay, this is left and right of a string. Then it will be order of n squared. It will work. Okay. Hmm. Yeah, it's also wrong. I can't always. Okay. If we would have passed a substring, then it might work. But here, that would be s of L. I equals to L while I is less than R, and we can take R as length. Okay. So what we are going to pass is return helper of 0 comma length of s. Yeah, that's good. So if s of I is equal to uh, dash I plus equal to 1, okay, so last can't be dash, so I can always use this part. So if s of I is equal is not equal to dash, suppose we are at here, we found a dash. Okay, so if we pass this string 2, 3 and 4, and if we found a dash, okay, and then what will pass, we will pass 3 and okay, 3 and okay. Yeah, like these all are just vague. Why am I doing this? I still can't understand. Instead of always trying to know how much dashes are there, I can simply take the count in the first at the first place. I will create an array that will keep the count of all the nodes. Yeah, that will work better instead of every time trying to find how many dashes are there. Hmm. So on odd index, I have I will have the what can I say? The node, the value of nodes, and the even index, I'm gonna have the dashes, number of dashes. So node underscore node not here. Node dash node dash. This is it will be an array of 0 cross not length of s for I in s for I in range length of s if s of I is equal to dash. If it's a dash, if it's not equal to dash, rather it is not equal to dash, node dash dot append cool, else temp is equal to 1 while s of I is equal to dash temp node. Instead of I can directly use count dashes. Okay, this count dashes that's equal to 1 if the next one is also dash. So we can start from it from 0. And here will be a counter, like temp equals to 0, but temp is equal to I, and this will be temp, and it is going to keep track of si, like indexes of s where it is dashed. Temp plus equal to okay. So instead of using for loop, I can also use a while here. I equals to 0 and while I is less than like this. So after that, I don't have to use a temp for it. I can simply use an I. So if I found that at any I, yeah, so here at any I, there's a dash, there's no dash, it is numeric. Then I will press equal to 1 else and append it into node dash, else I will count the dashes. So yeah, counting dashes is normal thing. I will count the dashes. So dashes are counted and stored in count dash. Okay. And whenever I will count all the dashes, then I can append all dashes. Okay. Node dash dot append count dashes. Yeah, so we can check it out also by printing. Let's print count dash. Node dash. Here the odd indices are nodes and the even indices are dashes. So we don't need this directly for now. Okay. Yeah. 1 1 2 2 3 2 4 1 5 2 3. Yeah, now it is looking cool. Not like 1 and 2. So for each odd index, the previous element for each event index 0 1 2, the previous index contains the number of dashes it has. So yeah, now we are going to use it in a pretty clever way to reach to our answer. So root equals to tree node of int of SL. Okay. So instead of passing, yeah, now we can pass L and R. So yeah, so root will be tree node of int of SL, and initially we have our count equals to 0. Okay. I do have to keep track of these dashes. That's what the problem is. But now I'm not able to find the way. Okay. If we are going to keep track of these dashes, its complexity will increase. So if we have left and if we have right, yeah, one more thing. We don't have to check all L and R. If we will take this L and R, then the next L and R will be this and this. So it is actually kind of a merge sort thing, like the same as merge sort, like calling two recursive function in order of it. So let's try to put one more variable in here. That will be our count. Okay, and initially count is 0. So our count is 1. For I in so every time our L will be an even number 0 1 2, and we have to traverse it till R. Okay, and or rather No, L will be an odd num, odd at L will be at odd index. Okay, so for I in range L comma R and 2, each time we are going to step at 2. If we found that array, oh, okay, node dash of I equals count. Okay, if it is equal to count, so it will be our left node. Okay, so and when we have found our left, then we will find our right. We will try to find our right. If right is at last, so the left node of this root, so left node comma right node equals then comma none. So we have this tree node root for each of the subtree. We will try to find left node and right node of that node, that root node. Then we will traverse the whole root. Like if this is 1, we will try to find, and the dashes before the 1 is 0, so it is at 0th level. So we have to find uh, the level. Okay, instead of count, I can actually put it level. It will make sense to you. Level. Okay. If this is level, then I have found my first node. First node. If I found my first node, so or left node, so I will put a flag here. Flag is equal to false, that I haven't found anything. And if flag and then I will put flag is equal to false. Okay, and update our left node as left node equals node dash of I plus. Okay, it will be a dash, so we won't have any problem. Else if node flash equal, if these two are equal, then I have gotten my right node. Okay, node dash of I plus 1. Yeah, so I found both of our left node and right node. So now I have to use the same helper function. Helper means it is like the same as this function, create tree. So I'm going to replace its name as create tree. It sounds better. Okay. So if left node that it is not none, then create tree and return root node of that tree. So root dot left equals create tree, and I will pass, what will I pass? Left and right of this now. So what will be my left of it? It will start from L plus 2. Okay, it will start from L plus 2 because L is the current node, L plus 1 is um, it's dash for the next node, and so I have to pass L plus 2, and the right will be K. So 1 dash 2, I have to pass 2 to 5, 2 to 4. So for 1 I have to pass 2 to 4 and 5 to 5 to 7. I have found that 2 is my left node. Okay. For 2 I have to pass 3 to 4. So all I am interested in is right node. I will pass right minus 1 and right plus 1. So L plus 2 to, what is the right node? Right node, okay, and right node. If both are there, either both will be there or only one will be there. Yeah. So if left node is there and right node is there, I will create two tree. The first one will be root dot left, which will start from L plus 2 and end at right node minus 1. Okay. So index of right node minus 1. Like it is will be minus 2 actually. So yeah. And the another will be this. It will start from right node and end at R. Hmm. This is root dot right. Okay. And return root. Okay. If L node, if there is L node, then root dot left equals same as create tree from L plus 2 to right. One more thing, I have to put the level also in here. Okay, so I will increase the level every time I'm going to another phase. This will be level plus 1, this will be also level plus 1. Hmm. Okay, and return root here also. Now we have to deal with the base cases. Actually, we don't need this much big thing. Okay, we can have done it in rather small way, but still no big deal. It's all also order of n. Okay, so order of n square. The whole thing is in order of n square. So when we are going to return none, if L is less than 0, I'm feeling I should have rather used n. Okay, no. R is if R is n and L is 0, like I'm calling it on true. Yeah, here. If I'm calling at 0 comma length of s, if I will be at 0 comma length of s, if L is less than 0 or R is greater than length of s or R minus L is less than equal to 1, then return none. Okay, so this won't be length of s, this will be length of node dash. That's why it was giving that kind of error. Okay, so there are more things. Instead of s, I have to use node dash everywhere. Node dash here. Okay. Again in here too. Man, 1 second. R S S. K K. Here I have created node dash of n. It should at least return root. So 1 is there. Okay, but 1 dot left over. Okay, so we have to check by printing left node and right node. Both are none still none. And so we have to use not flag. Oh, sorry. Instead, I can use true in here. Okay, it's still not working. So let's try to print each I and node dash I. Print I comma node dash and dash of I. Okay, and level. I have started level from 1. Okay. Node dash of I is 2, 3, 4, 5, 6, 7. Oh yeah, I have to start from L plus 1. Okay. So ln rr every time you have to insert string. Okay, in a node dash and int of set. So 1, 2, 2. There's a problem in left node and right node I. So let's print that now. Left node should be 2 and right node should be 5. Yeah, it is 2 and 5. If L node and R node, left will be L plus 2 to right node. L plus 2, okay, L plus 2 to right node will be 5 minus 1. Yeah, it looks cool. Dash level plus 1. Yeah. Then the next will be 3 comma none. 2 and 5. Then 3 comma 4. It should be 3 comma 4. I have increased the level to. So and root dot right, I have passing right node also. Okay. So left node and right node are actually indices. Yeah, it shouldn't be value. I have passed the value. It should be indices. Yeah, that's the problem. Now let's try it. Okay, cool. It worked on it. Let's see whether it will work on others or not. Well, this really took a lot of time to solve. Let's see whether it is correct. Okay. Yeah, it is working fine in here. We will try to input only single index to check it. Okay, so wrong answer. there are infinites of null here. We don't have to return every null. And that's one of the major problem. If I found 4, then it will append 4 instead of 401. Okay. So here I have to also put while. Yeah, same as above. Same as below, not above. Okay. So instead of count nums. Okay. Count nums. While si is not equal to count nums. Nums plus equal to 10 to the power count nums. Okay. Result, or rather node dash of I result. Let's use a variable result. Result plus equal to 10 into 10 to the power count nums into int of si. Yeah, this will work. 0 1, and at any time we found that it is equal to dash, we will append the current solution, nums. Okay, let's see. While I is less than length of s, and result, sorry, just separate result and count. I'm not doing count num plus 1. That's also a big problem. What? So it converted into palindrome. Okay. Yeah, of course it will. So append str of res of, now reverse it, not take it. It's quite amusing to solve it like this, but it's okay, and also it's lame. So at least we have our 1401, 349, 88, and 9. So 90. So the answer is correct, but this is vague. That's why it is not working. Okay, so instead I'm gonna append result and we'll try to find the way. Okay. Let's append the result for now. Result plus equal to s of I, int of s of I. Or directly s of I. And finally I will convert it into a string. Better. Result equal to string s, result plus equal to s of I, and finally int of s. Why was doing that much shit? Now it's simple. Cool. Everything's working fine. Let's try to submit. Yeah, it got submitted. Thanks. Okay, it's done. And again, let's revise what happened actually. So at first our question is, we have to create a pre-order like a tree from the pre-order traversal. So we do have our pre-order traversal, and it's given in this manner that the number of dashes before any node actually represents its level. Okay, so taking this as an example, let's take this as our example. If we have like 1-401 dash dash 349 dash 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 90 dash dash 88, what I did is I recursively start from root node. Like I have started from 1 and I tried to find, so before 1 there are zero dashes. Okay, so here there are 0 dashes, so I will try to find the number 0 plus 1 dashes in the whole sequence, in the whole string. So I found that at this place there is 1 dash, and nowhere at any other place there is nothing. So this must be our left node for 401 for 1. So 401 is left node of 1. Okay, so I will divide this as left part, and we don't have any right, so no problem. Now again we are left with this string. Okay, I have already counted all these dashes and appended it at even index, odd indices. So it is at 1, it is at 3, it is at 5, and dot dot in the node dash array. Okay, node dash array. Now for 3, 4, 9, 90 and 88, I will also pass the height of this. Like this is at height 2, like level 2. So if this is 349, so 401, yeah, we have this 401. What we did is we have this part, and the another part is we found this 401. This is, so after that these are the levels, dash dash dub single this dash. So we tried to find, for 401 we tried to find double dashes. So we found this first double dash, this is second double dash. So we divided into two parts. Okay, the first part is this, the second part is this. This will serve as now left node, this will serve as right node. So for this, left node is like 349 and 90, 349 and 90, and right node is 88. We have to check where is 349. It is directly connected to 41 or in the path to till 90. So for that, 349 and 90 is passed. In 349 we see that 349 is at first and then 90 at third level, because there are three dashes. So we will simply put 349 in here, 90 after that, and for 401's right we will take 88. Okay, so see, this has 0 dashes. Okay, this has no dashes. This has 1 dash, 401 has 1 dash. These both had 2 dashes, 349 and 88. These have 2 dashes. So for this level, we are going to use 2 dashes. 2 dashes are given. And for this level, there are 3 dashes. So that's how I calculated it. In here too, I calculated first the dashes here. Okay, how many dashes are there for each node? And here I recursively did what I have said. Pass this node, pass this to left, right. So I've created left node and right node, try to find the same number of dashes with as levels. Okay, and then I will created a tree in left and right. If there's no right node, like if I have found only one of the same case as this 401, we have only find 1 dash in 401, so there is no right node. Right node is this is none. Okay, this is none. So this was tutorial. Thanks.